Hi, my name is Yiheng from class EEE 6825 Pattern Recognition in University of Florida. My project topic is exploration of face recognition using MATLAB based on PCA algorithm. Firstly, the definition of face recognition should be discussed, since many different terms have been frequently used, which might lead to some unwanted confusion. Face detection. This task is to recognize which region in this picture is the face of a human. The most commonly used application is when we take a selfie using smartphone. It can be easily noticed from the screen that there is a rectangle around the face. Secondly, the face recognition, which is trying to match the face under test with all the pictures in the database, then find out which person in the database is exactly the person in a given picture. Thirdly, the face identification. This is the task try to find the person in database which has the highest similarity to the picture under test. In this example, this one has the highest similarity with the person under test, even though they are not the same person, which means this can be realized without face recognition. Well, in this project, I focused on the face recognition with algorithms of based on PCA. Here's the basic introduction of PCA. This is the term short for Principal Component Analysis, and it is also known as Eigenfaces method, which realizes the dimension reduction. Here, this flowchart shows the basic steps for PCA. In step 1, firstly, we should collect some original images. Since the variance of the pictures like the lighting source, angle of pictures, human positions, different expressions, or background, the first thing we need to do is the normalization. The normalization includes using a low-pass filter or compression. This step is trying to make sure we get the similar size of the pictures. The geometric normalization tries to rotate the pictures because the orientation of a picture and the angle of picture can be quite different. So by rotating the face, we can get the face region in the center of the picture. The face masking is trying to avoid the background, hair, or jewelry laying effect to face recognition. Here, the illumination normalization. This is the most important one because illumination can have huge effect to the face recognition. The same face in different lighting source can look dramatically different. After normalization, we can get the eigenvector through calculation. For PCA, it tries to find the maximum scatter matrix of the projected images. Now in step 2, since we get the eigenvectors here, now it's time to do the process of the images under test. The images would go through the similar process as the original images, then be projected to the existing eigenfaces. Finally, the step 3, using a classifier, we can determine the matching rate between one image under test and one of the original images. In order to understand the performance of PCA better, other algorithms are studied too. By comparison of PCA with other algorithms, we will have a better sense of the good and the bad of PCA. Here, I've read the paper about another algorithm called Fisher Faces, which is derived from FLD, short for Fisher's linear discriminant. Basically, under different lighting sources, the face of one person can look dramatically different. But according to the observations of author, there are two observations. First, for a Lambertian surface without self-shadowing, all the images of a person would fall into a 3D linear subspace of the high-dimensional image space. Second, certain region of the face would have high possibility of being with dramatically variance. As a result, these regions are less reliable, so we can remove them during the process. Based on these observations and combined with the Fisher's linear discrimination, the authors provided with the Fisher faces method for face recognition. The basic theory of Fisher faces are trying to maximize the ratio of the between-class scatter to that of within-class scatter. And this graph shows a comparison of PCA and FLD for a two-class problem where the data for each class lies near a linear subspace. And from the graph, we can easily notice that FLD performs better than PCA. So, conclusion can be drawn: in certain conditions, Fisher faces would outperform eigenfaces. Another method is also briefly introduced in this project. EP, which is short for evolutionary pursuit, with a flowchart like this. Here we can notice that EP is served in a sense like a hybrid of filter and wrapper. The basic theory for EP is to use non-orthogonal bases, which is expected to have a better performance. Also, in the reference paper, the experiment of comparison between these algorithms are presented too. And here are some conclusions. First, EP and PCA have better performance over MDF in terms of generalization abilities. MDF has better performance during training, while in testing, PE outperforms the other two. So, with the basic theory of PCA introduced, now I did an experiment of face recognition, just followed the steps mentioned above. MATLAB is used as the tool to realize it. Firstly, I chose 6 pictures to form the collection of original faces. Here, the image database I used is LFW, which is short for labeled faces in the wild. This database is designed for the study of problem of unconstrained face recognition. It includes more than 13,000 faces from the net, and the pictures are all labeled with the person's own names. Then, normalizing the color of pictures using function of RGB2 gray and resize the pictures using this function. After this, I got 6 blurry pictures. Then calculate the mean of the 6 pictures. And continue normalizing the pictures by removing the mean face. Using the covariance matrix to get the eigenvectors, so after this step I will get the eigenfaces. Here is the eigenfaces. Notice that the eigenfaces are quite dark compared to the original ones. Now, with the eigenfaces obtained, the test pictures can be projected into this space and be compared with the eigenfaces. I chose 3 pictures which are already in eigenphases, which persons are already in the eigenphases. And here shows the result. The test results are correct. Then conclusion can be drawn. MATLAB simulation results prove the feasibility and fair performance of algorithms based on PCA for face recognition. Okay, here are some references I mentioned above. Thank you.